Hi, good morning to everyone. I am Edaman Nagendra Babu studying BTech final year in Electronics and Communication Engineering stream. Firstly, I would like to say thank you for giving this opportunity, and I am doing intern at Emertxe Solution in Embedded Systems. Here, I am going to explain about the internship journey in Embedded Systems, internship, and also I could like to explain the implementation of microwave oven simulation. In this process, we as team consist of 4 members can explain part-wise of this video. My core team members are Ms. Vemala Bhubaneswari, Mr. Mallu Sai Kumar Reddy and Mr. Satyala Prem Kumar. Before going to explain the presentation, let me explain you the topics which are covered in throughout the internship, which are Introduction to C, what is embedded systems and microcontrollers, conditional loops and operators, arrays and pointers, functions and strings, storage classes, MPLAB IDE, XCV, PICSIMLab, introduction to various peripherals of PIC microcontroller of PIC16, F877A, interfacing various peripherals of PIC microcontroller, and also followed by multiple quizzes. And coming to the presentation, the main agenda contains introduction to microwave oven and what is embedded systems and its types, microcontrollers and microprocessors, what are the requirements and the project implementation, the working principle and simulation, followed by results and also conclusion. Introduction to microwave oven. Generally, a microwave oven is a relatively small box-like oven that raises the temperature of food by subjecting it to a high-frequency electromagnetic field. The microwaves are absorbed by water, fats, sugars, and certain other molecules which consequent vibrations produce heat. In this, we are going to implement 4 types of modes. They are as follows. One is micro mode, 2 is a grill mode, and third one is convection mode, and fourth one is start mode. Micro mode. This mode is used to cook food in a traditional way. It uses maximum power of 900 watts. In this, the maximum time that you set for cooking is 16 minutes. Second one is grill mode. This mode is used to cook meat. It works as a micro mode. User can set time as per the cooking time of food. Third one is convection mode. In this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements. The last one is start mode. The start mode is used to start the function by the user. In the first week, we have learned about the C programming language. In this mainly focused on conditions and loops, operators, arrays and pointers, functions and strings, storage classes, preprocessors, etc. The same language is developed by Dennis Ritchie for creating systems applications that directly interact with the hardware devices such as drivers, kernels, etc. Next, we have learned about embedded systems and its various types. Let me tell you what is the embedded system. An embedded system is a combination of any hardware and software which is intended to do a specific task. An embedded system is a microprocessor-based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as a part of a larger system. At the core is an integrated circuit designed to carry out computation for real-time operations. By observing the elements of embedded systems, it consists of input ports, output ports, memory, and other devices. When classifying embedded systems based on performance and functional requirements, embedded systems are divided into 4 categories. One is real-time embedded systems, 2 is standalone embedded systems, third one network or networked embedded systems, fourth one is mobile embedded systems. Types of embedded systems. Network embedded systems are usually general purpose processors. Standalone embedded systems work by receiving the input without using any ghost systems for desired outputs. Real-time embedded systems are designed to perform a specific task with a time frame, whereas mobile embedded systems are embedded in mobile phones, cameras, and various gadgets in etc. Moving to next slide, microprocessor and microcontrollers. A microprocessor is a computer process where the data processing logic and control is included on a single integrated circuit, that is IC, or a small number of ICs. The microprocessor contains the arithmetic logic unit and control circuitry required to perform the functions of a computer central processing unit. A microprocessor reads the settings input on the keypad into its memory. Signals are sent to the display to indicate the cooking mode and cooking period set. Coming to microcontroller, a microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. That is, on a single chip, we found all elements including CPU, memory, and its input-output peripherals embedded on a single chip. A microwave controller takes input from a keypad display output on an LCD display and controls a relay that turns the microwave generated on and off. Going to the requirements for the microwave oven simulation project, mainly we require this type of tools, that is MPLAB IDE software and also PiximLab. In PiximLab contains CLCD, that is character liquid crystal display, NKP matrix keypad, PIC microcontroller. It is a microcontroller where PIC stands for peripheral interface controls, 16F controls 16-bit processor on chip flash memory, whereas 877 is a model number and A is a revised version, and also the timers. PiximLab. PiximLab is a real-time emulator of development boards with integrated debugger. PiximLab supports some Pixim microcontrollers and some firmware microcontrollers. PiximLab have integration with MPLAB or Arduino IDE for programming the board's microcontrollers. MPLAB IDE. MPLAB IDE Integrated Development Environment is an expandable, highly configurable software program that incorporates powerful tools to help you discover, configure, develop, and debug and qualify embedded designs for most of our microcontrollers and digital signal controllers. MPLAB supports automatic code generation with the MPLAB code configurator and the MPLAB Harmony configurator plugins. CLCD. CLCD stands for Character Liquid Crystal Display. In PiximLab, there are two types of displays, that is 16:2 display and 16:4 display. A 16:2 display means it can display 16 characters per line, and there are two such lines. In this LCD, each character is displayed in 5x7 pixel matrix. In 16:2 intelligent alphanumerical dot matrix display is capable of displaying 224 different characters and symbols. Whereas in 16:4 display, it can 16 characters per line and there are 4 such lines. There is a popular 16:4 LCD with a green backlight. It displays the ASCII characters and some special characters also. There are two types of communication modes. One is 4-bit mode and 8-bit mode. Coming to NKP, matrix keypad consists of push button switches that are located at the column and row intersections of a grid or matrix, connected together as OR switches in the same column. As we can see in the following figure, when you press a switch, it connects to a row to a column. These keypads are mostly used in digital lockers, telephones, calculators, etc. Coming to timers. Timers are used to measure specific time intervals, but in electrical engineering terms, timers are also referred to as the counters often. The timer is a component which is extensively used in different embedded systems. They are used to keep a record of time for different events occurring in the embedded systems. The timer is a simply binary counter which is configured in a circuit or a system as per the need to count the pulses in the system. The value of the timer automatically set to 0 once it is as its maximum value. Timer is a software designed to count the time intervals between the events. Resolution, which is also called register with 8 to 16 bit etc. Quantum, which depends on the system setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar, may be 1:1 or 1:8. In Pixem Lab, we may found that PIC microcontroller. Here we can see that the PIC architecture of PIC 16F877A configuration. Here we may found there are 5 different ports, that is port A, port B, port C, port D and port E, and also we can see the timers and also the memory, USART, and also various elements like program counter, flash memory, file registers, instruction register, etc. These are the various tools which can be used to implement the microwave oven simulation project. Now I am forwarding this to our co-op team member, Mr. Mallu Sai Kumar Reddy. He can explain the project implementation and the working principle and the simulation process. Thank you. Thank you for giving this opportunity.
Hi, I am Mallu Sai Kumar Reddy, studying BTech final year, studying in Electronics and Communication Engineering. Here I would like to explain the project implementation and the working principle of microwave oven project. Firstly, let us know how a general microwave oven works. In microwave oven, a device called a magneton inside the oven produces microwaves. The microwaves reflects off the metal interior of the oven and causes the water molecules in food to vibrate. This vibration results in friction between molecules, which produces heat that cooks the food. We can see how the magneton produces microwaves from this block diagram here. Let us go for the simulation part. In order to implement the microwave oven simulation, in this Pixem Lab and MATLAB IDE, we need to follow up the following. The steps to follow while initializing the project. Go to the project, next click on Create New. Next, Microchip Embedded, next, Standalone Project. Next, select family which includes mid-range 8-bit MCU. Next, select PIC 6F877A. Then click on Finish. Select the compiler tool chains. This is XC8 compiler. Then next, give a name for the project as microwave oven or anything you would like to. We want the select project location and the folder, then finish. Create main.c files in source files. Create main.h files in header files. Further, move to Pixem Lab Simulator. There you may come across the following instructions like power on screen. It is used to power on the microcontroller. Then menu display screen. To display modes we select PIC 16F877A. Time display screen. It is used to display selected time. In that other there are 3 options like start, pause and stop. This stop is used to interrupt the running process. Then clear screen. It is used to clear each mode. Set time and set temperature. It is used to set time and temperature based on need. The following modes of operation we may get there are micro mode, grill mode and convection mode. In micro mode, it is used for heating the food items. We select one using push button in the display and set the time for minutes and seconds using keyboard. Second mode is grill mode, which is used for frying of food items. We select 2 in the display using keypad and set the time If it set to 20 seconds, after completion of 20 seconds, it again comes to display. Then let us use enter into the convection mode. It is used to cook the heavy food at high temperature. It displays different to other mode. We have to set the temperature in this mode in degrees Celsius. The temperature should not go beyond 250 degrees Celsius. So if I want to set beyond 250 degrees Celsius, it results invalid temperature as in the results. Coming to advantages. Simply, it heats quickly. The convection is the best parameter while using the microwave ovens. It cooks food faster than conventional ovens. You may see the results as follows. First one, the power on screen. Second, cooking mode display. Here we select the mode of operations. Third one is micro mode and grill mode, and fifth one is convection mode. In convection mode, if the input is beyond threshold temperature, that is limit, it displays invalid temperature. Like this, we may get the display results. Like this, we can implement the working of microwave oven simulation. I would like to forward this to our core team member, Ms. Vemal Bhuneshwari. She can explain the code implementation and the process of each mode of microwave. Thank you for giving this opportunity.
So now let's move towards our demonstration of microwave oven. Here we can see I have used the two softwares. First one is the MPLAB XIDE. This software is used for the programming purpose. Here I have written the whole code into the main.c and included these all the files over there. So let's first of all first we have to create a hex file into the MPLAB XIDE. For that we have to build our project. So I just build my project. So as we see here, build is successful. That means I don't have any error or any warning, and loading is also completed. So the hex file we have created just now, we just have to upload that hex file into the PiximLab simulator for the simulation purpose. So here I will just load the hex file. Okay. So first of all, it will start the powering on the microwave. As we see here in the code, at the first stage, it will powering on the microwave oven. This one, it will powering on the microwave oven for the some time. Then it will jump into the cooking modes like this. As we all know, microwave oven has the 4 basic cooking modes. That is the micro mode, grill mode, convection mode, and start mode. We will see all those modes one by one in details. So let's enter first into the micro mode. As we see here, by pressing the key 1, that means key equal to 1, we will enter into the micro mode. So I just press key 1. I have pressed key 1, and then it's showing the power of the microwave oven. So as we set it here, the power is equals to 900 watt. It will be displayed. Then next one is the timer mode. It will jump here. Our program will jump here, and we will see that the set time, that means the minutes and seconds timer, the next. So we will just set the time, like here I have set the 55 seconds, like, and 2 minutes 55 seconds. So for demonstration, this is the very long time, so I just clear it. If I press star, as here we see, if I press star, it will clear out the as per that. So I press out the star, it will first clear out the minutes like this here. Then if I press again, then it will clear out the seconds also and start the seconds blinking. So I will just give the 9 second for the demonstration. Then I will enter by pressing the hash. I will enter into that. Okay, so here 9 second timer will start. 9, 8, 7 like this. If I pause, like I have pressed the 5 is for pause. It will pause the timer as well as it will stop the fan, as we see here. I just will wants to resume it or start it again. If I press 4 here, it will start from that time I press here. Okay, so here we see I just turn on the buzzer. Okay, so here we see buzzer will on. Then next mode is the green mode. We will just move towards into the green mode. So here we see green mode. If we press the key 2, like if we press the 2, we will enter into the green mode. I just press 2 here. Same as the previous mode, we have to set the time here. Like I have set suppose 9 second, 9 second, 1 minute 9 second. Okay, so I entered into it. If I press 4, so it will as here if I press 4, it will automatically increment the seconds by 30. If I press 4 once, it will automatically increment 30, like this we can see. If I press at 2 times 4, then it will increment the minutes, like here the 2 I press 2 times, it will 3, like that. So by doing this, after when this time will be completed, we will come out that mode. Okay, so next one is the convection mode. As we all know, convection mode is the important mode of the microwave oven. Here we see if we press the key equal to 3, that means from the keyboard in the cooking mode display, if we press the key 3, it will goes into this mode. Here we have to manually set the keys, temperature. So I just go into the convection mode. Okay, here this one is the convection mode. So if I press here I have set the limits of the temperature like 250. If my temperature is goes beyond the 250, then it will give me the error, like it will show the message like invalid temperature, and buzzer will on, and after some time, like after some delay I have given here, it will turn off the buzzer. So I will just give the temperature more than 250. If I give the 69, okay, 639. Okay, so if you see here, invalid temperature. Okay, so if I give the temperature, any temperature below the 250, it will goes into the preheating. As we see here, it will goes in, else it will goes into preheating. Or here preheating time I have set it at 50 seconds. So let's move. Let's see if I give 123. Okay, enter. As we see here, preheating automatically start from the 15 as I have set it here. So up to this we have to wait. We didn't do anything in the preheating mode until the time will turn off. As in every mode, if we see, if the door will be on, it have to give us the warning that your oven's door will on, please turn off the oven. As we see here, I have mentioned that here buzzer will on, and it will display that please turn off your display door. So I press RB3. As we see, door status open, please close. If I release the key, then it will start again the preheating. So as we see into here into MPLAB IDE, we can use the different types of sections. This is the very reliable software, so we anyone can use or anyone can edit the code in this software as per their requirement. So here we have to use the main.c file as well as with the header files like main.h. So that the functions and object variables we have used here, we have to declare all that into the main.h file. As we see here, I have declared all this power on screen, clear mode, display, like that. So in the matrix keypad, I have to tell code about the matrix, and then in timers, all these things related to the timers. CLCD .h, this is the main.h. This is used for the CLCD.c. This one is the CLCD.c. Like this one is the CLCD display, as we see into the Pixim lab. Then this all are about MPLAB XID. As we see here, our setting time is turn out. That means our preheating time is finished. Then it will automatically turn off, turn back into our main screen. Then next one is, if I see, here, I will just explain the last mode. Here, okay. So last mode is the start mode. So here, okay, let's move. In the start mode, if we press the 4 directly in the cooking mode, we will enter into the start mode, and here we have set the starting time is the 30 seconds. If we move goes into start mode, it will automatically start the timer from 30 seconds. Let's see here. If we want to increase, if any user want to increase the time, he or she just press the 4, it will increase by 30 seconds. If double press, then it will increase the minutes. If single press, it will increase the seconds, like that. So at that time, the timing is going on, fan is on, and when the time is finished, fan is turned off, buzzer automatically turn ons. Okay, so that's it for all my explanation of microwave oven. Thank you so much.
I am Prem Kumar. I am here to conclude the project of microwave oven stimulations, microwave process technologies to easy to understand, and the thesis of embedded system programming language, inner field of the PIC stimulations, which can be using the C programming, and the storage of classes and timers structures to implement the stimulations PIC in the easy way and the better to implement in our daily lives applications and upgradation of technologies, point-to-point communication to the future vision, communication, wireless communications, and the technologies that implemented to day by day, and which can be using the simplest way to implement the technologies of the low power or the less number of timing to implement it, which can be using in our daily lives. That makes the life to vision of the applications of the future, that the upgraded future technologies that can be using. We observed the different modes of microwave processing, quick processing modes, and that makes the everyone to stimulated in the easy way of the future technologies. Who the mentors who taught the lessons and workshops and giving the opportunity to do internships. That's everyone to implement the embedded systems in our daily life, to adopt the vision and the applications and technologies to implement it in the easy way. Finally, I thank to the Emertxe to give the opportunity to do internship and everyone to have interest to the embedded systems of the workshops, the future technologies to easy to implement it in easy way, that clarify who the mentors workshops can taught gives the opportunities. We always thank and point out our daily lives of Emertxe, and finally we thank to the Emertxe vision of future technologies. Thank you.